Hello, Chuck Dieter here at the Headwaters Science Center with another afternoon Headwaters Science Center live show. And the last time I was talking to you by this medium, I was dealing with magnets. Magnets are kind of mysterious things. It's a lot of fun to explore and mess with them and see what they can do. And let's just review a little bit. Now, the way magnets operate is kind of mysterious. You've got one piece of material that by some strange property can attract others. It doesn't attract everything, but it can attract things, and it has what seems to be kind of a force field around it that can either attract things or repel things. Like, for example, we're using some of these magnets, and one thing we know about magnets is that they have poles, which is kind of a strange concept, but it's kind of like a force field that on one side pulls things, on the other side pushes things away. This is a magnet with commonly they're called a north pole and a south pole. Here's the north pole, let's say this is a south pole, and if two like poles, that is two north poles, come together, they push away from each other. I can feel that. I can't really push this together because I got that force field shoving it apart. And you can see it more clearly here. Let's clear some of these things out of the way and put it here on this tray so you can see. We can move these together. Whoop! And I've got a north pole adjacent to a south pole here, and you can see that when I get two opposite poles, they really have a pull. Just move that entire mass of a piece of metal that far. Look how far away it is, and wow, pulls it right over there. Are you seeing this on the camera? Okay, very good. Now if I reverse one of them so that two like poles, could be a north pole or south pole, but let's call them a north pole this time, are together at about the same distance, they start to interact, but instead of coming together, instead of attracting each other, they pull away. And if you change the angle just a little bit so that one of those magnets can swivel a little, it'll flip around so the north pole is adjacent to a south pole and attracts itself. They attract each other. Whoop, like that. Just happens kind of magically, doesn't it? I'm not saying it's magic. There's something scientific about it. Now, the idea of a magnet is, it's kind of hard to explain, but just a very rough idea, very basic idea, is that all things are made up of particles. And all those particles, atoms or molecules, all those particles have electrons whizzing around them, and they have protons in their nucleus, and then protons have a positive charge, electrons have a negative charge. But one thing scientists have determined is that when charges move, it produces a field, kind of a magnetic field, this mysterious force field. And they know that positive charges are attracted to negative charges, they're pulled together, and negative charges repel each other, positive charges repel each other, kind of like magnets. And there's a connection between electricity, between electrical charges and motion of electrical charges, and magnetism. Now, if you want to study that, that's a pretty complex subject, and you can explore and explore and explore and explore and learn all kinds of things with it. And it's kind of exciting to get into it. I can't get into it in this short period of time that we have today, but that's the idea. Now, in a permanent magnet like this is a magnet that is just, that's its properties. It's a magnetic piece of material. And if you could look down in here and see the particles, they'd all be aligned in a certain way, where the charge is all aligned in a certain way. And that kind of gives it that magnetic property. If you look at, say, let's say the steel in this pair of wire cutters, the particles would not be aligned. It's not magnetic, and the particles would be all randomly arranged. But in something that's magnetic, has a permanent magnetic property, the particles are arranged in such a way to produce that kind of a field, magnetic field. Now, there's different ways that objects can be made to be permanently magnetic like this. I'm not going to go into those right now. That's something interesting to study. But science have found out that there is a connection between magnetism and electricity. And we can make a temporary magnet by simply putting current through a wire and having a conductor next to it. Scientists have found out back around the 1830s or so, I think was when they first started studying this, maybe the 1820s, that when a current runs through a wire or any other kind of conductor, when a flow of electricity goes through a conductor, it produces a magnetic field. They also found out that if there's a magnetic field, say from a permanent magnet, and you move a conductor through it, it causes current to flow through that conductor. So there's ties between electricity and magnetism, and if you arrange them just right, a flow of electricity and something that can conduct electricity in just the right angles, you can produce a magnet. And this is a simple way to do it. You can do this at home too. Take any kind of material that is magnetic, which most commonly would be steel or iron, something with steel or iron in it, and wrap a coil of wire around it, like a conductor, just copper wire, and wrap a coil of wire around it, and put a current through it, say from a battery like this, you produce a magnet. Let's try that. I'm going to put some paper clips up here on the tray. And these are made out of steel, common mild steel. And right now, this piece of steel here, ordinary stock, won't attract them. So I'm going to connect the two ends of this wire that's wrapped in a coil around this piece of steel to a battery. And I am going to put on my reading glasses so I can see this more closely. And then connect the other end to the other terminal. I'm just going to hold it here because I'm going to want to cut the current off here. And I'm producing a magnet. You can see that it attracts, but it's not very strong. And I can feel that the wire carrying the current is heating up. That's one thing that's interesting, that every time current goes through a wire, it produces something called resistance, and that causes temperature to rise. Anyway, I've got 10 turns of wire around this bar. And one way to increase the power of a magnet, an electromagnet like this, is to simply increase the number of turns. This has 10 turns, and you saw how it weakly lifted these paper clips. This has 20 turns. And I'm going to connect this to power and see how well it works. And you can see it's quite a bit stronger. And that's one handy thing about temporary magnets, electromagnets, is that you can turn them on, establish the magnetism, and then cut off the current and turn them off. They lose their magnetic properties. Well, technically, actually, they do retain some magnetic properties for a short period of time, but they're very weak and they don't last very long. They're going to dissipate. And once you run a current through here, what happens is the particles in here, the atoms in the steel, all kind of align in a certain electromagnetic alignment where their charges all align, and that produces a north pole and a south pole, and you have a magnet. Now when you cut off the current, that effect ceases and they go back to their random arrangement. Now another way, let's see, where's my other magnet here? Oh, there it is. Another way to possibly increase the power of a magnet is to reduce the resistance of the wire in the coil. Now here we had 10 windings around this magnet. You saw how weak it was. 20 windings here, quite a bit stronger. Now let's see, I'm using a slightly heavier gauge wire. And if you have come here. A heavier gauge wire will actually allow current to flow more freely and reduce resistance. So I'm going to see if I can use these 10 windings here to make a slightly stronger magnet, see if it works. Well, maybe not. Maybe it didn't make much difference. And by the way, I am experimenting here just to see how this works. I like to experiment with this kind of thing. Okay. Maybe a little bit stronger than the 10 windings of the smaller gauge wire. Let's see if 20 windings make a difference. Connect this to one terminal. Bring this around and try it again. Oh yeah. That's pretty strong compared to the other one. So far, our electromagnets are nowhere near as strong as these permanent magnets. I wonder if we can change that at all. Let's compare the two. Now, I'm not saying that electromagnets can't be made strong. They can be made strong. I mean, you might have seen, say, in a scrapyard, an electromagnet picking up cars and putting them in a crusher. Picking up cars or picking up huge masses of scrap metal. And that's a common thing, common use for electromagnets, because you can pick up a huge mass of metal, put it over a bin, cut off the current, and drop it right in. Now I have here a ruler. I'm going to try another little test here. I'm going to let's take a steel ball about this size. See if we can make it stay on the end. And I'm going to move this permanent magnet closer to it and see how far away we can have this before it starts to attract the ball. Okay, that was about, okay, this ball is about 1 centimeter in diameter. And so there's a difference of 5 centimeters to this point. I'm just going past that point a little bit. Oh my goodness, you know what? I think we magnetized this a little bit. There's a little chunk of something on it, so it doesn't roll as well. Let's see if we can find another one. Here's another ball that doesn't have something on it. Put this one right here. I'm going to move this closer and closer and closer. And see when that thing starts. Whoa! Difference of about 6 centimeters. Over here and now what caused that? Look at this. How did that happen? When we first did it, when this hadn't been touched by a magnet, and we moved this closer to it, it attracted at about 6 centimeters. But I moved this all the way up to a distance of about 2 centimeters before the steel ball moved. Why would that happen? Look at that. Okay, here we go. I'm going to try it again. You know, sometimes when a piece of magnetic material like steel comes in contact with a permanent magnet, it actually develops a little magnetism itself. So I wonder if, what happens if I reverse this? We're getting a polarity factor here? That's interesting. All kinds of things, when you start experimenting, all kinds of factors get into, start to have an effect on what you're doing. And sometimes you don't know what's going to happen. Well, I've got an idea here. I've got a piece of aluminum here. It's a conductor. It's not magnetic. So I can take, say, I don't have another piece of steel like that, but a piece of steel like this. This is steel. And put it next to this magnet, and it attracts right away. It supports its own weight, things like that. I'll take a piece of aluminum. Nothing. Aluminum is not magnetic at all. but would it work for an electromagnet? Let's find out. Let's take a little bit of this red wire here. And I'm not going to count the windings on this. I'm just going to see if we can make an electromagnet out of aluminum. I bet you we can't, but won't know until we try it. So let's see. These wire cutters are pretty beat up. I don't know if I can get it to strip this wire easily. Got to get the insulation off so we can make a contact. Oh goodness. There we go, there's one end. I'm gonna tape this on with some electrical tape. If you're doing this at home, whoops, let's give ourselves a little bit of wire room here to play with. If you're doing this at home, you can use masking tape or anything else, it doesn't have to be electrical tape. Let's put some turns around here. See if we get any magnetic response at all. Okay. Now let's just grab a paper clip and see. Yeah, let's use this end first. Yeah, it doesn't matter. I'll set that on there like that. It's magnetic. We did produce a magnet. Let's see if it attracts. Nope. No magnetic attraction whatsoever. I'm going to set it there. Not even going to try to pick it up, just set it there and see if it clings to the aluminum. Nope. Nothing. So it has to be something that can be magnetized, something would be attracted to a permanent magnet in order to make an electromagnet. And one other thing we found out about permanent magnets was if you stack them together, North Pole to South Pole, we have another one here, somewhere around here. There it is. You can increase the power of them. Let's try that small steel ball again. Here, maybe we can see this just as well on the table. Probably can. Yeah, definitely. This picked up a little magnetism. It's attracting little bits of stuff. I'm going to move this close and see how close we can get it before that ball starts to move. Turn it like this. Whoop. Uh-oh. Well, I did find out that this is a little bit magnetic. Okay, now what you can't see is I'm seeing little tiny markings on this ball, and this has actually developed a South Pole and a North Pole. And as I get the magnets closer, this is actually spinning. I wonder if I can do that with a larger steel ball that you can maybe see better. Let's see if we can stay put here somewhere. I'll just hold it. Much heavier. Let's maintain a little contact here. Maybe this will actually become a little bit magnetized and actually spin a little. Probably couldn't see that, sorry. I'm just playing here. Anyway, that's the idea. You can do some experiments at home with this. You can try different gauges of wire. You can try different windings, you know, just add more windings to increase the power. Let's see, let's try this with 20 windings here. And see how close we'd come to the power of one of those permanent magnets. Oops. Okay, like that. And I'm getting well, this has got me fascinated now because I found out with this electromagnet we made, at first it attracted the ball from quite a distance away, and now it's not attracting the ball much at all. I'm going to have to maybe go back to the computer or back to a book and read up on this and figure out why that's happening. I love it when that happens. I love it when I try experimenting with something and I find out that what results I get are not the results I expect, or that the results seem to change in the middle of the experiment. Weaker and weaker. Well, I'll have to find out about that. Anyway, I think that's about enough time to be talking about this stuff. And check us out again tomorrow. We'll have another show at 3:30, and I'm not even sure what the subject's going to be, but